Okay, guys, please solve this question. You can just pause the video right now and you can resume to look at the solution. All right, guys. So many people, first of all, solve this question from the point of view of like set theory and Venn diagrams. So integers which are multiples of 2, multiples of 5, and multiples of 7. Okay, they can be drawn like this. And if I ask you what will be number of elements of A union B union C, that would denote the numbers which are divisible by either 2 or 5 or 7. Now, in this question, we want to find out the numbers which are divisible by none of 2, 5, and 7. So from the 120 numbers that we have, we subtract the numbers divisible by either of them, either of 2, 5, or 7. This will give us the answer. Okay. So numbers which are divisible by none of them, it is basically 120 minus number of elements which are there in A union B union C. So now we know this from set theory, guys. Number of elements in A union B union C is number of elements of A plus number of elements of B plus number of elements of C minus number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C plus number of elements of A intersection B intersection C. Let's take A as this set, multiples of 2, B as this set, multiples of 5, C as this set, multiples of 7. So number of elements in A denotes the number of elements divisible by 2. Since we have numbers from 1 to 120, I have 60 numbers which are divisible by 2. Similarly, number of B denotes numbers divisible by 5. Since I have numbers from 1 to 120, I have 24 multiples of 5. And since I have numbers from 1 to 120, there are 17 multiples of 7. Up to 17 sevens are 119. Minus numbers divisible by both 2 and 5 means multiples of 10. There are 12 such numbers. Minus numbers divisible by 2 and 7. 14. 14 ka we have 8 multiples. 14 8s are 112. Next number is 126 out of this range. Next, we want the numbers divisible by 5 and 7. 35. 35 ka we have 3 multiples. 35, 70, and 105. And last is A intersection B intersection C. Numbers divisible by all three. 2, 5, and 7. That is 70. There's only one such number, that is 70 itself. So this total is 60 plus 24 plus 17 plus 1, that is 102. And from that you're subtracting 12 plus 8 plus 3, 23. That is nothing but 79. So A union B union C is 79. From 120 you subtract 79. You have your answer 41. Option A. Now this is one way to solve the question, guys. I'll tell you another way, and in that we use the concept of Euler's number. So what does the Euler's number tell us? Euler's number is the number of terms which are less than and co-prime with the given number. For example, if you want to find out the numbers which are less than 12 and co-prime with it, you find the Euler's number of 12. Now, how do we find the Euler's number of 12? Let's prime factorize 12 as 2 square into 3 raised to 1. So numbers which are less than 12 and co-prime with it can be found as 12 into 1 minus 1 upon 2 into 1 minus 1 upon 3. The logic is every third number is a multiple of 3. So in a given set of consecutive numbers, 1/3 numbers will be multiples of 3. The remaining 2/3 are not multiples of 3. Similarly, you have half the numbers as divisible by 2 and half the numbers not divisible by 2, right? So basically the numbers which are less than and co-prime with the number 12 can be found as 1 by 2 into this will be 2 by 3. That is basically 4. And we observe, guys, there are exactly 4 numbers which are less than 12 and co-prime with it. And they are 1, 5, 7, and 11. So same thing we'll do. Okay. Same thing we'll do here. 2, 5, and 7 have the least common multiple, that is 70. Nearest multiple of 70 to 120, it's basically 140. So we start by prime factorizing the number 140. 140 is 35 4s. So 2 square into 5 raised to 1 into 7 raised to 1. So how many numbers are less than 140 and co-prime with it? Same logic, 1 minus 1 by 2, 1 minus 1 by 5, 1 minus 1 by 7. This will be 140 into 1 by 2 into 4 by 5 into 6 by 7. So 5, 7, 35, 2 is 70. What remains is 2. So there are 48 numbers which are less than 140 and co-prime with it. okay, in terms of 2, 5, and 7, right? So what we are going to find now is the numbers which are lying between 120 and 140 and remove them from 48 to get the required answer. So we have 121 itself, which is not divisible by 2, 5, or 7. 122 is divisible by 2. 123 is not divisible by any of them. So 123. 124 is divisible by 2. 125 is divisible by 5. 126 is divisible by both 2 and 7. Then we have 127, not divisible by any of them. 128 is a multiple of 2. 129 is not divisible by any of them. Then we have 130 divisible by 2 and 5 both. 131 is not divisible by any of them. 132 is divisible by 2. 133 is divisible by 7. 19 sevens are. Then we have 134 divisible by 2. 135 divisible by 5. 136 divisible by 2. 137 not divisible by any of them. 138 is divisible by 2, and we have 139 not divisible by any of them. So 7 numbers among these 48 are lying between 121 and 140. Your answer is 41. So that's another way. Now, many people are much comfortable using the set theory concept. Many people have already studied the concept of Euler's number. So it depends upon your preference. You can choose a method.